All right, next up, we're going to take a look at what a catalyst does and how this affects K. So here we have on the left energy. Over here we have reaction coordinate or just reaction. So we're going to take a look at it in a reaction coordinate diagram. So in this case, we'll have reactant over here, product over here, and then we'll say this is the non-catalyzed direction. Right, and if you think about this, we have kind of an E of A, an activation of energy in the forward direction. And then we have an E of A, an activation energy of the reverse direction, right? So one's forward, one's reverse, the activation energies. And then if we add a catalyst, right, that will lower the activation energy, right? So when we catalyze a reaction, we lower the activation energy. And so you can see when we've done this, we've lowered the activation energy of the forward reaction, but we've also lowered the activation energy of the reverse direction. So we're kind of making both ways faster, and we're making them equally faster, and so it ends up having no effect. So a catalyst decreases the activation energy of both the forward and reverse direction. And so it ends up having no effect on K. On Q/K. We will not shift the equilibrium, but we will get to wherever we're going to faster. And so we've already touched on kinetics, right? So this kind of zone in the middle here, how we get from point A to point B is more kinetics. And then what actually is point A and B is what we're talking about right now, the equilibrium constant, right? With kinetics, we're talking about how fast you get to the end point. Now we're talking about what the actual end point is. And so this is K, and so this is dependent on thermodynamics, which we'll touch on in deeper detail later on. But for right now, we're just going to say kind of K is what it is type of thing. We'll learn about why when we get to thermodynamics.